Physics Part 9. Well, there are scalars and vectors. And when we talk about scalars and vectors, we certainly talk about the quantities and the direction, of course. Scalars and vectors. At the end of section, we should be able to distinguish what are the scalars and what are the vector quantities. Give examples of each. Add or subtract. Coplanar vector. Represent a vector as two perpendicular components. Use a vector triangle to represent forces in equilibrium. All the physical quantities have a magnitude and a unit. For some quantities, the magnitude and units do not give us enough information to fully describe the quantity. For example, if we are given the time of which a car travels at a certain speed, then we can calculate the distance traveled. However, we cannot find out how far the car is from its starting point unless we are told the direction of the travel. In this case, the speed and the direction must be specified. A quantity which can be described fully by giving its magnitude is known as a scalar quantity. A vector quantity has a magnitude and direction. Some examples of scalar and vector quantities are given here. The quantities such as mass, weight, speed, velocity, force, pressure, electric current, temperature. Well, either they are scalar or vector. If we talk about mass, it's scalar. If we talk about weight, it's a vector. If we talk about speed, it's scalar. If we talk about velocity, it's a vector. When we talk about force, it's a vector. When we talk about pressure, it's scalar. Electric current is a vector, but temperature is a scalar. Although the athlete runs 10 km in the race, his final distance from the starting point may well be 0. Some scalars and vectors. Well, I can have an example for you. A big wheel at a theme park has a diameter of 14 meters. The people on the ride complete one revolution of 24 seconds. Calculate A, the distance ride moves in 3.0 minutes. B, the distance of the rider from the starting position. A, in 3.0 minutes, the rider completes 3.0 into 60 over 24 is equal to 7.5 revolutions. Distance traveled is 7.5 into circumference of the wheel is equal to 7.5. 2 pi into 7.0 is equal to 330 meter. B, 7.5 revolutions completed. Rider is 1.5 revolution from starting point. The rider is at the opposite end of the diameter of the big wheel, so the distance from the starting position is 14 meter. Now it's your turn. State whether the following quantities are scalar or vectors. A time of departure of a train. Gravitational field strength. Density of a liquid. A student has a part-time job earning $5 per hour. He works for 4 hours and then spends $12. Calculate and decides whether each quantity can be described as a scalar or a vector. The total amount that have changed hands, the balance. Vector representation. When you hit a tennis ball, you have to judge the direction you want it to move in as well as how hard to hit it. The force you exert is therefore a vector quantity and cannot be represented by a number alone. One way to represent a vector is meant by an arrow. The direction of the arrow is the direction of the vector quantity. The length in the arrow drawn to the scale represents its magnitude. This is illustrated in the figure. Representation of the vector quantity. The addition of two scalar quantities which have the same unit is no problem. The quantities are added using the normal rules of the addition. For example, a beaker of volume 250 centimeter cubic and a bucket of volume 9.0 liter have a total volume of 9,250 centimeter cubic.